Good morning, good afternoon, good evening, everyone. Thanks for joining us for a day in the life of the DevSecOps professional. This webinar is brought to you by Snyk, Red Hat, and PortShift, and we really appreciate you finding time for us. As we all spend more time online, innovation becomes more important in both our business lives and our professional lives. Containers and Kubernetes enable innovation and also require changes to get the most out of them, require changes to the way that we work together as teams. So today, we're going to provide some examples of what those kinds of changes look like and some practical things that you can take away with you and back to your work. I'd like to introduce today's presenters. I'm Kirsten Newcomer, Director of Cloud and DevSecOps Strategy at Red Hat at our Cloud Platforms BU. Jay?
Hello, everyone. My name is Jay Yeras. I'm Head of Cloud and Cloud Native Solutions Architecture here at Snyk.
Dave?
Yeah, hey, everyone. So my name is Dave Muir. I'm the Global Partner Solution Architect at Red Hat for our security ISVs. I've been in the security space for about 10 years now and was recently hired into Red Hat to focus on our wonderful security ISVs like PortShift and Snyk.
Great, thanks, Dave. Ariel?
Thank you, Kirsten. Hello, everyone. My name is Ariel Schupper, and I'm a VP Product Management in PortShift.
Great, thank you all. And you'll be hearing from all three of our panelists as we go through today's webinar. We wanted to start by just kind of acknowledging that as all of us are spending more time online, so are the hackers. Right. So, and because of that, we think it's really important that, and because of the way containers and Kubernetes work, right, DevSecOps is more important than it ever was. So if we just take a quick look at the top threats to cloud computing, a couple of things will kind of leap out. One, data breaches. For any of you in the States, we know that a number of unemployment insurance fraud is tied back to data breaches from some time ago. Don't know whether that kind of thing is showing up in other parts of the world as well. Misconfiguration, inadequate control, phishing, of course, through account hijacking through phishing, insider threats, insecure. But we're really focused on how can we help address all of these threats for containers and Kubernetes in particular, through the capabilities that Red Hat, Snyk, and PortShift bring to the market. Again, I don't really want to read all the threats. They're here. When you get the slides, you'll also have a link to the content and can read more for yourself. Similar to the overall set of threats we see for cloud computing, there are top threats for container security, right? Vulnerable packages or dependencies in the image. Again, configuration concerns related to the deployment settings. Sometimes images or pod deployments ask for more privileges than they really need. Access to the host file system network. Sometimes this is malicious and sometimes it's just a simple oversight. The way you really tackle these problems is going to be the same, whether it's malicious or not. Excessive account permissions, that is for the service account, say that's deploying the application. Container networking, service-to-service communication is a key element here. And of course, how you manage secrets as well. So there are definitely security methods available to help manage all of these threats. Typically at Red Hat, we think about container security in three major buckets. You need to defend the infrastructure for your container and orchestration platform. You need to control application security and, as needed, extend the security capabilities for the platform with the broad ecosystem of partners that Red Hat has. We aren't going to talk about all of the methods listed in this slide today, though we will hit on many of them. I want to kind of stress that even though kind of the technology changes, including the security technology that we use for containers and Kubernetes, many of the same principles still apply. So really what you're seeing here should not be new if you're a security professional, you're thinking about how to secure these environments, but the tooling that you need to use can be new. So as we work, as we go through this webinar, you'll be learning, again, some very concrete, practical information that you can use to secure your DevOps environment. So we're going to be talking both about how Snyk can help you introduce security in the very early stages of your CI/CD pipeline, how OpenShift provides support for the pipeline itself and for securing the platform, and then how PortShift can extend those security capabilities kind of all together. So we'll go ahead and jump in. Again, there's many more things available to you from Red Hat and our partners, and we're going to cover in today's presentation, but we're going to get through as much as we possibly can. So, Jay, let me hand over to you.
Thank you, Kirsten. And thank you to all the attendees that chose to spend your time here today and learn a little bit more about how you can improve your security posture. So I want to dive a little bit deeper on that previous slide, the DevSecOps pipeline. And what I'm going to do is I'm going to talk a little bit about Snyk and the products that comprise our platform, and how that fits into that pipeline to help you secure your workloads. Snyk. So the Snyk platform is comprised of a couple different products that you can leverage today. Snyk open source, Snyk container, Snyk infrastructure as code, and the Snyk Intel vulnerability DB that we use to fuel some of the insights that will be presented to you when you leverage some of these. So what I've done is I've also wanted to go into detail on the specific ones that I'm going to use in this example, which will mainly be the Snyk open source and Snyk container. And I have something special for you, Snyk. We'll talk about Snyk open source first. So a lot of this really, when we talk about shifting to the left, you might be using tools today to scan your application code. Maybe some static code analysis tools, things like that. But are you evaluating the dependencies that are part of that application? This is where tools that provide what's called software composition analysis come into play. And Snyk open source provides that for you. It allows you to discover and identify any vulnerabilities that may exist in your open source dependencies. And it also provides you actionable insights to be able to fix those vulnerabilities early on in the process, so that you don't have to worry about them later on down the chain when you get a report from your security auditors telling you that you have all these vulnerabilities that you need to fix. You'll have that insight early on in the process. Snyk. So the application dependencies are part of the equation, right? If you're building modern applications today, or if you're considering to build modern applications today, there's a number of different layers, and containers undoubtedly is one of those. So where we're also looking at, while we're looking at our open source dependencies and vulnerabilities that might exist there, the fact is that there are also some vulnerabilities in the container images that we're consuming. So Snyk container allows you, in the same manner as Snyk open source, to get visibility into what these vulnerabilities are. Not only are you able to evaluate the base image that you're using and get actionable insights on recommendations for upgrading that base image, but you also get application insights as well into that source code and those dependencies. Snyk. So I promised that there was something special. So what I've done is I put together a self-paced workshop that goes hand in hand with this presentation and kind of guides you through this example. We talked about that DevSecOps pipeline earlier on, and there were some logos there, and I wanted to kind of illustrate firsthand with some guided exercises on how you can actually implement this tool and how easy it is to really do this. So if you're using tools like this today, that's great. It's a good start. I also encourage you to take a look at how you can expand and improve that security posture by including additional checks and balances in that pipeline. And that's what we'll cover in that workshop. We'll go through these steps. Now, I'm going to talk a little bit about that here today. And if you're interested in following along, you can open up a new tab in your web browser and visit solutions.snyk.io, and you'll kind of walk through some of these exercises as I'm talking through them. Snyk. So I have a simplified version of that pipeline. And this is what I would say, this is how you would secure your workflow using Snyk. There's a couple different components to this simple pipeline, and it starts at the source. So we have the ability of being able to provide visibility into these open source dependencies right from the IDE, leveraging our integration with CodeReady, Red Hat CodeReady. And then there's also a couple other integrations that we're going to talk about, like our source code management integration, and how we can monitor those repos for any vulnerabilities that might be introduced later on, and how we can fix them. The other part of the process is when we start building our application, and I'll include a couple of techniques that you can utilize today using the Snyk CLI to be able to scan those applications as well as the container base images. And then monitoring. Once we deployed our application, being able to monitor for additional workloads that might have been introduced out of band, and how you can remediate those as well. Snyk. So Snyk is proud to have partnered with Red Hat and worked together on delivering the Red Hat CodeReady dependency analytics powered by Snyk. So what this is available today in the Visual VS Code marketplace. And you can download this. It integrates right into your IDE. And what it does is it provides insights into those open source dependencies right from within the IDE. So once you open up, in this example, package.json, you'll see all your dependencies, and then you'll also be able to hover over each of those and get additional insights into what those vulnerabilities are. Hand in hand with this is the powerful reporting that comes with CodeReady dependency analytics. And here you see in this screenshot a consolidation of all of these issues for your application, as well as some interesting tabs like those vulnerabilities that are unique to Snyk. So you'll be able to, again, to get powerful insights on what's going on in your code and what you can do to solve some of these. Snyk. So I mentioned source code management integrations. This is an important component. You want to start monitoring your repos if you're not already, so that you can start getting an assessment of what these vulnerabilities are. Now, I know I'm over here in the West Coast of the United States, but I could hear the pain of, Jay, why are you telling us to show all these vulnerabilities? Well, you have a lot of technical debt. Your developers are pushed to produce new features, and I get it. Having to get a long list of things to fix is cumbersome, and you have to prioritize. But prioritization is key. And we're here to make your life easier. And one of the things that we offer with our SCM integrations, for example, is the Snyk priority score. So there's a number of different vulnerabilities out there, and some of them are a lot of them are high severity vulnerabilities, but they're not all created equal. And there's a number of factors that go into that. And we want to make things easier for you, and we want to help you prioritize these accordingly. So the Snyk priority score is a proprietary-based algorithm that is used, and it factors in a number of different objective and subjective variables to come up with a helpful prioritization of how you should be approaching some of these vulnerabilities to help you mitigate some of those constraints, right? Because you do have competing priorities. You have to ship your product as quickly as possible, and then you have all this technical debt that you have to resolve as well. Another part of this also is with our pull requests. So from within the Snyk console, once you've identified these vulnerabilities, you're able to open a fixed PR against that repo. And we lessen the burden of figuring out what dependencies or transitive dependencies are affected by this, and all these vulnerabilities, and we provide you with a simplified means of just literally having a one-click button that solves these for you. So again, very powerful tools that not just provide the discoverability, but again, gives you those actionable insights. Snyk. So the next phase, we talked about different components to that workflow, and we talked about source and application dependencies, and we've covered that. Now we move on to building a container image. Many of you are familiar with this already. You can experiment with this from the command line. In this example, I'm kind of going through a sample exercise here. And again, the screenshot or the animation might be a little bit small, but if you're going through and walking through this as well through the workshop, you'll be able to see it a little bit clearer, but I'll speak to it. So Snyk also offers a lightweight, flexible, but powerful CLI. And this can be used in a number of different ways, but it can also be introduced in your existing CI/CD pipelines to do additional scanning of your application, and also importantly, your container images as well as they're being built. And what I'm doing in this example is doing just that, taking a sample Docker file, building that Docker file, but I'm also scanning that Docker file with Snyk. And what I'm doing in the process as my container is being built is I'm also bubbling up what are some of the vulnerabilities that are there in my container image, and on also what I can do to fix those. Snyk. So in this example, my workflow included storing my container image in Red Hat's container registry. So what I'm doing here also is monitoring for those vulnerabilities within the Snyk console. And what I can see is that I've had a recommendation to upgrade my base image. So I'm using in this particular application Node 6. And the recommendation is that I should upgrade to Node 14. And the reason is that it's going to lower my vulnerability count. So I'm mitigating some of this and improving my security posture just from doing a simple thing, and that's just upgrading my base image to a higher version. And I'm able to see the exact details of what those vulnerabilities are, and I can make an informed decision on whether or not that's appropriate for me or not. Snyk. So another component of this, we talked about the container images, and now we've talked about securing those container images. But now what happens when our application has been deployed? And in this case, we're deploying it to a Kubernetes cluster and on OpenShift. So we have Snyk operator. Again, we worked with Red Hat and we published a Snyk operator that runs on an OpenShift cluster. And what it does is it monitors my applications, my Kubernetes applications that are running, on Kubernetes on OpenShift. So Snyk. What this is going to do is I can add additional workloads as now that the operator has been running on my cluster. And what this is going to do is give me another dimension of where my security posture is. And what I'm looking for here are the misconfigurations in my applications. So this example again is purposeful. I wanted to show some failed instances here. These are missing or incorrectly configured security context within my Kubernetes manifests. And what this is doing is it's bubbling these up again, so that gives you visibility into some misconfigurations that you might need to address. Now, they're not vulnerabilities, but they do expose you to potential breaches and things of that nature. So you definitely want to be aware of these, and you also want to have a plan in place to be able to mitigate those as best possible. Snyk. Now, this is all great, but what does it look like in the real world? Well, I wanted to include a couple of different examples. And when I was working through this and going through the vulnerabilities for this example application contains a number of vulnerabilities, and it does so intentionally because it's used for demo purposes. So what I'm doing here is highlighting three in particular. One of them is the ST package. So this is a Node.js application. There's a front end and a back end component to it, and it's running in that cluster. What ST does is it allows for simple things like the about page. So this application in particular, as I said, has a web front end, and it's a basic to-do app. And it includes an about page, and that's great, but it leverages this package. What this does is exposes you to directory traversal. So this example on the CLI is me pretending to be a bad actor. And basically, I've identified your host, and now I'm going to execute a couple commands in the CLI to list the contents of your directory. So I'm able to navigate and then potentially exploit some of those by manipulating some of those files or compromising information. So again, what is the risk of knowing about this and not addressing it? Well, you've just put yourself at the mercy of a potential bad actor to be able to exploit some of these. Snyk. The other one I wanted to kind of highlight here was cross-site scripting. And this comes to us by way of the marked package. Now, the marked package is used in our application because it allows us to include some markdown in our to-do app. So what you see here is a screenshot of the to-do app called Goof. And what I have on the other side is a little snippet, a code snippet. So I'm going to cut to the chase with it because I can also substitute some markdown with some JavaScript. Now, this one's very benign because all I'm doing is really just providing a pop-up here, but it's intended to illustrate the point. And the point is that I could also include some malicious code there as well. So I have access to the application, and now I can introduce some JavaScript in there that can do some other potentially bad things to your environment. So again, important to know about them and important to see about to see how these are could potentially be used in the wild by some potential bad actors that are aware of these vulnerabilities and are able to exploit them. Snyk. Now, the third one that I wanted to bring up is probably one of the worst ones, right? So this is regular expression denial of service, and this comes to us by way of the MS package, which is transitive to the humanized MS, which was included in our application. And what this does is it basically does a simple conversion of time. So I can do reminders for myself like, hey, I need to patch my servers in the next hour or so. Well, what it's doing though is if I have access to the terminal again from the terminal, I can issue some commands and I can actually interact and create some of these alerts as well. And if I do a mismatch, you might notice in my snippet of code, I've purposely misspelled minutes with incorrect spelling. What this will end up doing is it'll go through recursively and then just end up crashing your system. It'll be a denial of service, right? So I don't recommend you actually execute this one if you are going through the workshop and end up implementing some of these. But it's important to note that, again, some of these can be very powerful and can actually bring down your systems. And nobody wants to have that day where they have that escalation. So this kind of wraps up my portion. Again, I encourage everyone to go through the solutions.snyk.io site and take a look at some of these examples, because I will walk you through on how to implement all of these components that I mentioned, like code-ready dependency analytics, the source code integrations, the container registry integration, and then deploying Snyk operator. But I don't want to leave you with doom and gloom. I want to pass this off to my good friend Dave, who's going to talk about Red Hat's Secure by Design platform and how it can help you, again, improve your security posture.
Great. Thanks so much, Jay. And just before Dave jumps in, I want to appreciate just kind of restate all the elements of the pipeline that Jay called out, right? You have capabilities available to you right in the IDE, whether you're using code-ready containers for developing on your laptop, code-ready workspaces for a shared environment for all your developers. The integration with Snyk gives the development team upfront information about issues they need to address much sooner than if you wait until even the CI process or, worst case, the CD process to get that data back. Integration available also in your container registry so that you have multiple locations for this, and the great guidance that Snyk provides to help the development team. Dave, over to you to talk about
Kirsten,
OpenShift. Yes.
There is a question in the Q&A for Dave, and there is a poll after Dave's presentation. So I want to remind the audience.
Thanks, Ariel. So, Dave?
Yeah, thanks. I was going to point that out as well. There's a poll going on, a couple questions that we'll get to, but really appreciate that session there, Jay. It was all good stuff. And yeah, I plan to talk about Red Hat's Secure by Design platform. I got to tell you, I love the Snyk code for changing the next slide. I'm not as creative. I'm just going to say next slide, please. So if we go to the next slide, it's really talking about, if you attempt to implement the community version of Kubernetes, it's really difficult because you have to add all of these extra things on top of it. And of course, by the way, this isn't a slight on Kubernetes. If you visit the docs at kubernetes.io, you'll find a section entitled, what Kubernetes is not. And you'll see a handful of items like that relate to these bullets, like Kubernetes does not deploy source code or does not build your application. You'll see other things. It doesn't provide application level services or dictate logging or monitoring, alerting. But of course, you're going to need all of this stuff in an enterprise and a whole lot more, which you can see listed here. And so the risks associated, with that, with trying to get that community version of Kubernetes done right, becomes pretty straightforward in my mind. It's, the adoption of your teams using Kubernetes dramatically decreases. Trust in the platform that you're trying to implement is in question because you'll need to figure out all of these security controls, which I've highlighted here in the bullets. The next slide, please. Now, the good news is you don't have to look any further. You can just let Red Hat do all the hard work for you with a secure by design platform. That includes all these features. And all these features have been designed with security in mind. It starts with a container host, which of course is Red Hat Enterprise Linux and CoreOS. And so in order to secure your containers at the boundaries and help you protect your host from container escapes, you want to look at the 4 red pillars in the diagram to the right. So you have SE Linux, that provides mandatory access controls, namespaces for multi-tenancy. You've got secure computing mode to control system calls, and then control groups. That allows you to isolate resource usage on things like CPU and memory. Now there's a ton of security features included in OpenShift. Some are shown here in the bolded list to the left. And I'm going to take you through the ones in bold over the next few slides. So next slide, please. And of course, we all saw Jay talk about Snyk powering Red Hat code-ready dependency analytics. And to add to that conversation and sort of continue the journey of a DevSecOps professional, I wanted to mention Red Hat's cloud-native IDE product, which is called Code-Ready Workspaces. It's based on Eclipse Che, and the dependency analytics plugin is one of the plugins available in Code-Ready Workspaces. Now, being a former developer myself, I know it may be tough to transition off of a traditional laptop based IDE setup. But there are a couple of things that frustrated me that are shown here in this slide, which was onboarding to a new project, and then the whole, it works on my machine issue. So the upstream Eclipse Che project from the beginning set out to resolve these issues with a different paradigm. And it's basically to place everything the developer needs in a set of containers so that the developer can have their own pod, feels like your own laptop, but everything is easy to share because it's the same environment. And especially relating to our discussion today, everything's more secure because the source code is protected because it's not in some laptop, some hard to secure laptop somewhere. The next slide, the next thing that a DevSecOps professional would want to think about in their day is what security controls do I add into the CI/CD stage in my pipeline? Well, Red Hat offers OpenShift pipelines. This is based on the open source project Tecton. It's a Kubernetes native serverless CI/CD technology. Now, pipelines by nature isn't necessarily a security feature. However, it's a critical integration point for application and analysis tools like Snyk, SCA tools, software composition analysis tools, and analyzing images. And this is really a natural evolution of the features and integration Jay was talking about, because pipelines offers a very simple way to hook in these tools through tasks And the team at Snyk have actually done some great work on creating a set of Tecton tasks, say that really quick 10 times, that are available on GitHub. And so in the next slide, I'll transition over to a demo that shows you how to deploy OpenShift pipelines and run a Snyk scan in only a couple minutes. So let me go ahead and your hub and search for OpenShift.
Dave, you are on mute. No one can hear you.
Oh, thank you, Snyk. Thank you, Ariel. Let me go back then. Yeah, I forgot that puts us all on mute. OpenShift and looking at the operator hub where you can easily find the OpenShift pipelines operator and install it. And then if this is already installed in my cluster, so you can see it here, installed operator. And once it's installed, you'll get this pipelines left navigation item, which is shown here. And then in order to create pipelines, and if you have a custom task, you'll need to install that here. So I'm showing you the Snyk node task, the Node.js task. It's a real easy command. You can either use kubectl or OC to apply this YAML file and then create your secret, which contains your Snyk.io token. Once you do that, that will actually create a task for you in the project, in the namespace that you've created in. So if I go to my pipelines demo namespace, you can see the Snyk node task there that's now been installed. Now, if we go to the pipeline, I have a pipeline that has actually scanning the same application Jay just showed you. So I'm going to just edit this pipeline, delete the Snyk node task, and show you how easy it is to add it back in. So because I installed it from the command line, it shows up in that dropdown, and all I have to do is click the node task and configure it. And you can either do a Snyk test or Snyk monitor and fill in other parameters as well. One of the parameters is an input resource. So a resource, the Tecton resource, is things like a GitHub location or an image. And to create that resource, which you see created here, is very easy as well. If you go over to the OpenShift docs, it'll give you a command with a TKN resource create command, ask you a couple questions, and this is an example of basically creating a Git repo. So I've done that. That resource is then added, and it's very easy to then add that into your pipeline. Now, pipelines, you can add tasks in a serial format, or you can add other tasks in parallel. So it's very easy visually to create, an entire pipeline. So for example, you can say I'm doing a git clone, I'm doing a builda, and then creating an image, in this case, S2I Node.js image. Now, if we look at some of the pipeline runs here with this Snyk task, we can see there's 3 here. We'll take a look at one that failed, and it actually failed by design. This is a Snyk test run, and this basically failed because there's a bunch of vulnerabilities, right? Same application that Jay just talked about. And it provides you all the details and some remediation information as well. Now, if we go and look at the successful run, this is a monitor, Snyk monitor, and this places the results and pushes the results up to Snyk.io, which you can see here in the project that I own up on Snyk.io. So that is the video. Let's see if we can go back to the slides now. Perfect. Thank you, Kirsten. Yeah, so now I wanted to transition a bit to more of runtime security controls. And one of the features I talked about in the beginning of my section was SE Linux. And so one of the ways to see that SE Linux is enabled is through security context constraints. And they're called in upstream Kubernetes pod security policies. So this feature controls permissions for pods. You can use SECs to define a set of conditions that a pod must run with in order for it to be accepted into the cluster. It's like admission control. The example shown here is a restricted SEC with an OpenShift. And you can see that pods here with a restricted SEC can't run as privileged. They can't access the host network or ports. And so really the purpose of these SECs is to ultimately limit the ability of the container to negatively impact the infrastructure. And there are 8 different SECs that exist in OpenShift by default. Now you might be asking, so why are there 2 different names? Well, pod security policies, which are based on code from Red Hat, are in beta right now in the community version of Kubernetes. About 5 years ago, this feature did not exist in Kube. So Red Hat needed a way to deliver these capabilities to customers. And in OpenShift 3.0, we gave it the name Security Context Constraints. All right, next slide. And let's start talking about network security in the next slide. And one of the features to really look at is service mesh. And this helps you with network segmentation. This is especially useful if you're building cloud native apps. OpenShift service mesh is a dedicated infrastructure layer for handling service-to-service communication. And it's responsible for connecting, securing, and monitoring microservices-based apps within OpenShift. And as is tradition with Red Hat, it's based on open source products or projects like Istio, Kiali, and Jaeger. And as you can see here, Gartner's recommendation is to use a service mesh for segmentation, authentication, authorization, but also that you should look at augmenting the service mesh with a third-party tool to harden it, which is exactly what PortShift can do for you to automate the complexity of microsegmentation configs in Istio. And Ariel will talk more about that coming up shortly. And so on the next slide, and this is something else Ariel will talk about, is network policies. This also contributes to network segmentation. So I wanted to spend a couple minutes to discuss and demo network policies. Basically, a Kubernetes network policy is a specification that like the one you see here in the YAML, and it details how groups of pods are allowed to communicate with each other and other network endpoints. So I will go to another video here. Got to remember to put myself off mute when I start it. For this video, you can see that I started with a screen capture of my desktop background, which rotates, but this one was my middle child. She actually is 17 years old right now and still gives me these faces. We go on with the demo. This is an example that is actually out on GitHub on Red Hat's security demos, and you can run it yourself. But it's basically showing how pod-to-pod communication works with network policies, and it works with 3 different projects. So I created 3 different projects here. All have a client pod, Red Hat Demo 1, 2, and 3. And the third one has this hello world container as well. So if we go down to the network policies, there's no network policy defined, which means all communication is available. So I'm going to RSHH into one of the client pods and then run a curl command to that hello world, and you can see I'm connected. Now I'm going to create a network policy, and when you do that through the UI, it's very easy. It provides you samples of different network policies and visuals of how that all works. I'm going to create the limit access to current namespace network policy, which is the deny other namespaces policy. And if you go back You can see that was created. This is in Red Hat Demo 3. So I'm going to go back to my command line, try that curl command again, and you can see, voila, I now cannot get into that pod through another namespace. So that was a quick demo, but you can go through that same lab. It's really easy and explanatory lab up in the Red Hat security demos. All right, so if we go back to these slides, I'll wrap up my session. We've looked at a couple security features of OpenShift, but there is just so much more value that OpenShift provides. If you remember my slide about Kubernetes done right is hard, well, Red Hat has spent the last 5 years with both open source communities and our customers getting Kubernetes right. And the result is what you see in this slide. It's important to note that OpenShift is Kubernetes, plus all of these out-of-the-box additional services for both developers and operation teams. You know, instead of trying to implement this all yourself, why not use a supported and trusted enterprise Kubernetes platform that has all of these included services and things like hundreds of defect and performance fixes, 200 plus validated integrations. You get continuously delivered security patches. This is the value of Red Hat and OpenShift. Okay, so that does it for me. I will hand it back over to Kirsten, who will introduce the next session with Ariel on PortShift.
Great, thanks so much, Dave. Terrific to see kind of those capabilities available by default in OpenShift. Appreciate the demo of configuring network policies, right? This is one of the areas of real value in Kubernetes as well as OpenShift, both network policies and service mesh capabilities. That said, right, it does require configuration. The simplest way to configure your network policies, as Dave showed, is so that all pods within a particular kube namespace or OpenShift project are able to talk to each other. But microsegmentation can give you a lot more control than that. And so I'm going to hand off to Ariel to talk about some of the additional value add in protecting the runtime.
Thank you, Kirsten, and thank you, Dave, for the great presentation. And as Kirsten pointed out, let's talk about what can go wrong. So you passed all the checks in the CI/CD, you fixed everything, your deployment, and now you think you can sit down and relax, but things can go wrong. How do we know? We just need to check the headlines. So Kirsten, if you can make like 3 clicks. So one click is from recently, just 2 months ago, a campaign which was discovered in Azure Kubernetes. There's another attack which was discovered by the Aqua research team about containers, which post-deployment start attacking, and just misconfiguration that can cause any challenges. So Kirsten, if you can move one slide next. And you ask yourself, what can go wrong? What did I do wrong? I passed all the checks, everything was perfectly fine. But now we can see that since typically most containers are compromised post-deployments, but interestingly, a lot of those attacks stem from just security misconfiguration. You expose your dashboard, either the Kubernetes or you expose an applicative dashboard. You use an unauthorized image or an unauthorized registry. Maybe you didn't put in list privileges. Kubernetes offer a very powerful tool that you can restrict the powers and restrict capabilities of users, groups, service accounts, which allow you, of course, to minimize the potential impact. And as Kirsten and Dave mentioned, you forgot to put network policies. Everyone can communicate with each other. That means that if I did something wrong, the attack can propagate between the different elements in the cluster. Next slide. I want to go with you and kind of dive into one of the most common misconfiguration that we see over and over again. And this is a recent disclosure from Microsoft Azure Security Center. So the Azure Security Center discovered a crypto mining campaign on Kubernetes cluster. And the campaign was targeting Kubeflow. Kubeflow is an open source framework for machine learning tasks on Kubernetes. It's a powerful, popular application which is being a lot in use. Now, one of the I would say the promising things about machine learning tasks is usually you run them in clusters where the nodes have multi CPUs. A lot of them are using GPUs, so you have a lot of compute power under your hand. Now, when they analyzed a series of attacks which they discovered, they found out that one common thing for all of those compromised clusters was the fact that the dashboard was exposed. The Kubeflow has a dashboard, and this dashboard, which we'll show you in a minute, is very powerful, can do a lot of things that almost unrestricted permissions. And what happened was that this dashboard, the Kubeflow dashboard, was exposed to anyone's access. Now, the default deployment of this dashboard was through using an ingress gateway, using Istio for network, for all the network connectivity, for network policies, and using the Istio ingress gateway to create routes and restrict it, or at least the default setting requiring the users to do local host tunneling, which of course is a bit more restrictive, limited capabilities. And what happened was that users just modified this ingress gateway policy to turn it into a load balancing service that allow all the developers and all the users to just simply access the dashboard. The challenge was that not only developers and users access it, but also some malicious actors access it and use these powerful clusters to run multiple crypto mining sites. And this is just a simple misconfiguration that caused a use damage. Can you go to the next slide? Now, the surprising thing about it's not something new. So exposed dashboard, for those who are monitoring or tracking the security world of Kubernetes or the potential attacks, know that all the famous attacks, all the notable high-profile attacks which were reported somewhere around 2018, 2019, we're all using the same mistake. There was an exposed dashboard. No one knew that the dashboard is exposed. All of them were using Kubernetes dashboard. I don't know if they were using, but definitely they were deploying it. Now, before Kubernetes 1.11, all the dashboards were exposed without login. Even if they had login, it was mandatory. You can just skip it. The dashboard was exposed to all the services. And more importantly, dashboard had capabilities to do any kubectl command. So any cluster admin command, any command that a user can do, the dashboard was able to do it. So that's pretty much giving the keys to your safe to everyone who just wander around and looking for an exposed dashboard. And I'll show you in a minute how easy it is to see that as well. Can you go to the next slide? So now, while perhaps Kubernetes dashboard exposure is much harder these days, because it's deployed with minimal role-based access control. So their RBAC is minimized, and Kubernetes is a little bit restricted. In order to log in, you cannot just pass skip or put in, 111. You need to have a bearer token, which you need to create. And of course, it's deployed in the kube system namespace, so it's easier to see if it is used or not used, or perhaps not to expose it to all the services. And again, if you do want to check how's your Kubernetes dashboard behave and where it is, it's fairly easy to touch it. You can look for the label Kubernetes dashboard, and it's easy to detect it. Now, it's much harder to detect applicative dashboards like the Kubeflow. How would you come to think that you have a workload which have, the dashboard workload, you have running multiple workloads. You can see, I will show you in a minute how many pods this typical application, this framework spins up. That's a lot. And then you ask yourself, how would I, find, or how would I secure myself? So one of the tips that we in PortShift do in order to avoid those misconfigurations is do a careful inspection of the role-based access control and the role banding. We want to check what roles were attached to each pod or to each service account application. And we will see verbs that either use create, update, or use star. And we look at the resources and see resources which are using, elements like pod, deployment, service, endpoints, services. We understand there is something here that, is very powerful. Then our next check is to check if are those powerful pods or powerful service accounts Also using services which are exposed to the public. If someone can access them from the outside, they're using like load balancing services if there is a route from the ingress gateway, and we're making those checks to verify that no one by mistake opened this door for everyone. One more click. And let's go through a quick demonstration of how you can detect and protect. So first, you can see this Shodan tool. This is just an example of a tool that you can use to find publicly facing endpoints in the internet, right? And if you can see the screen, and Christian, if you can put it on a large full screen, then you can see that we deploy here on our cluster, we deploy this Kubeflow. And you can see that two things caught our eye. One eye was the Argo UI, and the second one was the central dashboard pods which are being deployed. Now, in order to check if those are really has some significant exposure, what we did, we analyzed their permissions, their role, what roles were what role binding those resources had. You can see that if I look at PortShift UI and I look for all the high risk owners, and then it's easy to find a central dashboard. I'm going to say it. When I look at the central dashboard and I click on it, I see it has two high risk. If I want to analyze those two high risks, then I can find that I have a cluster role and I have a namespace role. If you look at the cluster role, which is a bit suspicious, you can see that I have authorities on events, namespaces, and nodes, which is probably like powerful resources I need to pay attention to. And if I look at the namespace role, then you can see the secrets are exposed. Then my next stage is to understand that I have a resource which can access my secrets. Okay, access all the nodes, the services, and the endpoints. That's the important thing. Now you understand that why you need to do this. At least the default policy behind the ingress gateway was to use the port forwarding. With port forwarding, I can make sure that no one can access it unless he's part of the cluster, which is a fairly relatively a good technique. Now, what users did was to change it because it's problematic, it's challenging, and they moved it into public facing. Now, in PortShift, if you go to the runtime, okay, and then you can check that the deployments, we detect those workloads which are public facing. We also detect workloads which were changed or modified, like the policy was modified and changed post deployment. Now, after understanding that we have an exposed dashboard, the next thing is to define the network policy that will prevent it. And this rule, which can apply to a specific dashboard or to any dashboard, is just allow that if you want to prevent external access from your pod or from your dashboard when you're detecting it, it's very simple to define it. We use a service mesh to allow to powerful policies. And now we block it. I apply the policy, and I have this rule that blocking any communication between external users and our dashboard. So any external attempt to access our dashboard will be blocked, as Dave showed before in the network policies. If we move to the next slide, this issue shows the importance of network policies and how we can, and the setting of those policies. Now, sometimes all of it can be like a big pain, require a lot of settings, tuning, multiple systems that monitor and govern, and have potential for mistakes. Now, in PortShift, we believe that, creating a network policy is essential. Adding Istio to the game can definitely provide very large benefit to users, just because with the ingress gateways, which is much more powerful and has more capabilities now to restrict and to govern what the access into the cluster. The policy engine for internal and external or other resources is very powerful, and also encryption can be done seamlessly, and this is very important as a precautionary step for all your traffic. But again, it requires a lot of configuration, and sometimes it could be neglected. And the key for successful policies, we believe, is in the shifting left approach. So if we're going to let developers define those network policies, okay, and those policies will be automatically deployed into the cluster when the service is deployed, that would be like a huge leap, huge step forward. Now, obviously, we need to let security teams to create like framework or guardrails that within those that have like higher priorities or govern the rules that developers create, so we can make sure that the corporate policies are still maintained. But nevertheless, giving this power to developers will smooth things, will make them faster, will assure that we don't expose things unintentionally. Next slide. So what we PortShift believe and what we create is the ability for developers to create network policies manifests, which include the services, the permissible communication, what can be accessing the services, what the servers can access, exposure to external communication, and of course the encryption state. Now, those policies can be deployed as part of the Helm chart or any configuration file which is being deployed, and then when we PortShift, we scan those configuration files, we automatically apply this rule, obviously making sure that you do not contradict with the existing default rules set by the security team. Next slide. So in the next slide, I created like a small example, and this is an example of this kind of a manifest. So you can see that there's a CRD or PortShift policy. And the metadata is the name of the service we want to use. The internal access, you can see with the Postgres database. External, we allow the service to communicate with any external services, but we do restrict internal access to this service. And this is just, you can add this as part of your Helm charts where you define and you manifest all the services and the deployments of your new service. Next slide. And this is just a small example of how it's been done. In reality, is that this is our YAML file, the one that we just described. You can see it over here. Then the next stage would be to scan it as part of our CD scan. So when you want to deploy it in PortShift, we scan the deployment file. So we'll scan this YAML file, the CRD. When it's ready. So you can see in the bottom of the screen this Helm command, the Helm PortShift command that we scan this Helm chart. Let it run for a second, and then the result is going to be shown here in the network policy that now we can have this PortShift policy. Our Nginx pod can communicate with the front-end pod, which both were part of the services defined in this YAML file, in this CRD. Now, PortShift, our security, we secure. Just a little bit about PortShift. We secure users from CI, CD, deployment, and runtime. We usually integrate in the CI to check vulnerabilities, to look at the Docker CIS benchmark, to sign the image. At the CD phase, we scan for permissions, security context, secrets, and network policies. In deployments, we just harden the deployment. We verify deployment is secure. The role-based access control is defined, is not overly permissive. And in runtime, we allow users to create declarative network policies, which are essential for microsegmentation. We try to simplify this deployment, make it easier for users to deploy and to segment the network, traffic encryption, and of course, cluster protection, protecting cluster from anomalies. Yes, next slide. We can go to the next slide. So the benefit of deploying PortShift operator into the OpenShift cluster, one more click, we are an agentless solution. It's an admission controller, so there's no need to deploy agents on every node. You can get a single pane of glass for your containers and OpenShift elements security, and we can provide you this vast protection that we just discussed. Next slide. PortShift also integrate with Kubernetes Network Security. We integrate with Istio Service Mesh. Okay, so we're using Istio to provide zero trust inside the cluster and outside the cluster, so you can secure the cluster. We can expand it to resources which are outside the cluster. We can create, multi-cluster communication, and we can even expand the certificate to use external CAs for those who are sensitive for their CA signing and require extra level of security and at this point as well. Next. That's about it for my side. Thank you very much. Great. Kirsten, you got the stage.
Great. Thanks so much, Ariel. So as promised, right, we have walked through some practical steps and tooling available to you to implement those steps using both OpenShift, Snyk, and PortShift. For those capabilities, again, you get to leverage the built-in capabilities of Red Hat tooling, including CodeReady and OpenShift, the integration between Snyk and CodeReady, the integration between PortShift and OpenShift. So if you want to supplement the built-in RBAC, security context constraints, the built-in, make it easier to use network policies in OpenShift, easier to kind of evaluate the service mesh policies that you might implement with OpenShift Service Mesh, integration with the Tecton pipeline, all of that is available to you through Red Hat and our partners. And I hope that you have seen concretely how these solutions can be used to assess for vulnerabilities in your container images, provide guidance on how to address those very early in the life cycle, assess configuration issues. As we noted at the beginning of this session, misconfigurations are one of the main ways that both cloud-native solutions and containers and Kubernetes solutions become vulnerable. You can assess for excessive permissions and excessive role bindings. You can look for exposed secrets. Again, we can help you manage your network policies and your mesh policies in a much more automated fashion. So that's what we had for you today. I think we have a few minutes left to do Q&A. So I am going to stop sharing and maybe ask for some final comments from our presenters. Jay, would you like to start? And maybe turn on your camera?
Yes, thank you. A little slow there.
Sorry.
Yeah, no, once again, I just want to thank all the attendees for participating in today's webinar. I hope you found the information that we provided useful, and hopefully you'll be able to implement some of that. I did go ahead and respond to some of the folks that had some questions already. Again, if you're interested in taking a closer look and even following through some of the examples that I presented today, those are available today for free at solutions.snyk.io. And you can go through those self-paced workshops. You can also try Snyk. We have a very generous free tier as well. So it's very simple to sign up, and you can take a look at the product and evaluate and see whether or not it helps you. But thanks again, everyone.
Great. Thanks, Dave.
Yeah, thanks, Kirsten. Similar to Jay, just wanted to thank everybody for attending. And, what I wanted to just mention is that if you think about this day in the life of DevSecOps, this is really bringing together an enterprise solution, for your enterprise, not just, hey, this is Kubernetes and I need to piecemeal these things together. If you think about CNCF and all the hundreds of different certified technologies that you can place and install on top of Kubernetes, it gets pretty daunting. So I think, hopefully this was a good example of an enterprise solution that you can deploy today.
Great, thanks. Ariel, any last thoughts?
Thank you, Kirsten. No, I think I second Jay and second Dave. I think, Security is not an afterthought. You need to plan it carefully. You need to make sure you don't neglect. Sometimes things can go wrong, not purposely, but it happens. And you need to stay tuned and monitor yourself.
Great, thank you. And so if there are any additional questions, I think we have answered everything we're seeing in the Q&A today. Apologies, I know there were a couple of Chrome notification things that showed up. I don't know if they were in recordings or what, but heck, that's life online these days, right? So also wanted just to kind of final remark from me is to say that the tooling and technology are key. Automation is key for this new world, but culture is a key part of this scenario as well, right? And so we hope that maybe one of the things that this recorded webinar can help you with is something that you can show to your dev, your ops, and your security teams to help them understand ways in which we can work together collaboratively in a new fashion with new tooling and new technology to ensure that jointly we are protecting the applications and the solutions that we deploy that bring business value from the threats that are out there. So thank you again for your time. Be safe, be well, and we'll look forward to meeting with you another time. I guess I did forget to put up email addresses at the end. Maybe I should just do that really quickly. And you're welcome to reach out to any of us to do too many controls. There we go. So I will. All right. Thank you all.
Thank you, everyone. Thank you, Kirsten, for this great moderation.
Yeah, thank you all.
Thanks, everyone. Take care.